So again, these problems are just like the ones we did yesterday in the notes. So those notes we took yesterday will be really helpful. So for the first one, the first step says to do what? Factor, right? It says factor it and then rewrite the radicand using prime factorization in standard form. All right, so we're going to factor the 28. What goes into 28? 7 times 4. Okay, 7 is prime, but 4 is not. So 4 is going to be 2 times 2. And so what we want to do is we want to rewrite it so that the inside is, instead of 28, it's going to be the standard form for the prime factorization of 28. So what's that going to look like?
2 times 2 times
2
2.
times 2 times 7.
Oh. Yeah. That was a 2.
All right, now, the next step, this is an easy one, says to do what? Circle the factor pairs, right? So looking at the standard form of the prime factorization, we're looking for pairs. We're looking for 2 of a kind. Do we have 2 of a kind anywhere? We've got a pair of 2s, right? So we'll circle that pair of 2s, and that's it. That's all we have to do for that step, right? Now the next step, this is the tricky one. This is the one that that really makes this all work. So remember, this 2 times 2 is 2 squared.
Sorry, that was going to be on the other one.
So since the 2 times 2 is 2 squared, the square and the square root are going to cancel each other out. So what happens with this? It's going to become, it's not going to be squared anymore. Remember, the square and the square root cancel each other out. So the 2, first of all, there's only going to be one 2 now, and it's going to be on the outside. Exactly. So since the 2, the square on the 2 cancels out the square root, that 2 ends up on the outside. Now, there's nothing that's going to cancel the square root with that 7, so what's going to happen? The 7 stays on the inside. Okay, so how do we factor the 80? 5 and 16, and 5's prime, right? Okay, how about the 16? 4 and 4, and then each of those 4s is? Okay, so each of the 4s is 2 times 2. So then, when we rewrite this problem, what's that going to look like? Should have 4 2s and a 5, right? Is that what you got? So I got 1, 2, 3, 4 2s and a 5. Okay, now, we're not quite done rewriting this problem. This 2 times 2 times 2 times 2 times 5, that's the 80. But what are we missing? We're missing the square root. Anything else? Not yet. We're still missing one other thing. Anybody see it? This 5 out front here. All right, so this is the first time we've seen a square root that has a coefficient to start with. But if there's a coefficient there to start with, we need to make sure we keep it there. All right, so don't forget about that 5. Don't just leave it off because, well, it's important. It's part of the problem. All right, so now that we've rewritten the problem, we changed the radicand to the standard form of the prime factorization. Now we're going to look for what, Ryan? Okay, we're going to circle our pairs. So we've got a pair of 2s here and a pair of 2s here. So we have 4 2s on the inside, but that's going to become how many 2s on the outside? How many 2s are we going to have on the outside? 2 or 4?
Wait, no,
2, right, exactly. Because this pair of 2s here is going to become 1 on the outside, and then this pair here is going to become another 1 on the outside. So what we have on the outside is going to be the 2 times 2 that was on the inside. But then what else is on the outside already? That 5, right? So that 5 is also on the outside. Okay, now this is the 5 that was out here to begin with. What about this 5? Is that going to be on the outside? No, that's going to be on the inside. So it's going to look like that. All right, are we done? Brian? There's one more thing we need to do, right? What's that? Yeah, the coefficient. So, what's 2 times 2? And then 4 times 5? Perfect. So in the coefficient we get 20 when we multiply that out, and then inside the square root in the radicand we get 5. That didn't change because there wasn't anything to multiply out there. Since 4,500 ends in 2 zeros, what goes into it? 100. We know it's going to be 100 times what's left when we take those 2 zeros off? 45. So we know it's going to be 100 times 45. Then the 100 is going to be 10 times 10, and then each of those 10s is 5 times 2. And then how about the 45? Five and 9, is that what I heard?
Yeah.
And then the 9 is 3 times 3. Alright, that wasn't so bad, was it? So we need to make sure we get all of them here. It looks like we have 2 times 2, and that's all our 2's, right? Just those 2. And then a couple of 3's, so times 3 times 3. And I think that's all the 3's. And then we have some 5's. Did I get everything? I think I did. Okay. So I'm not done with this step though. I rewrote the 4,500 using the prime factorization, but what do I need still? What do I need still? I need the square root, and what should I put between these two steps? Yeah, put an equal sign between the steps to show that they're equal to each other. Okay, now what? Circular pairs. Alright, so do we see any pairs here? There's a bunch of them, right? We got a pair of 2's here, got a pair of 3's here, got a pair of 5's here, and that's it. So again, keep in mind, each of these pairs is a square. So the square cancels the square root and it ends up on the outside. So on the outside, what are we going to have? And we're done, right? No. We need to simplify that. 2 times 3 is 6, and then 6 times 5 is 30. So on the outside we get 30, and then on the inside the 5 doesn't change, so we get 30 square root of 5.
Mr. Bedtime.